Okay, we are going to be back tonight with a piece of Lego. No, we're not. We're going to be back with a new IC and some fun. And this is going to lead into, we're going to go back to doing another Arduino project. And continuing with the joystick projects. And they're going to be combined. And this is going to, I'm going to use this IC with that project. For the heck of it, because there's no real point. But it'll be kind of fun. I've used this once before, and I've got a lot of these. So I want to try and find uses for them. So what we're looking at today is the 4511 CMOS chip. So this one here is for the HEF brand one. I think this one says CD. This is a Texas Instrument one. Doesn't really matter, it's the same thing. So what does this IC do? Well, it's for controlling these things. Not that one, these ones. So it's for controlling these little single digit LED thingies. What are they called? Single digit display things. So we're going to have fun trying to get one of these to work and getting this thing to work. So I am running a bit low on these little boards. I'm not too sure where my extra supply are. I've bought quite a few of these over the time. So we may have to end up using this one. I've got a lot of these that I haven't used, but I don't find these ones as cool as the other ones. So we might use a little tiny one if they don't have enough space. So, well, I think they kind of have to all go on the. I think we can get them all on the one board. It's not that hard, is it? We can have the buttons because I want to have a couple of buttons. That's right. To actually, I'm just going to check which is the best way around for me to have this thing. I kind of feel like that would be the best way because I want the buttons down here. So I'm going to have some buttons here and they're going to control this and they're going to change the digit. So I think that makes sense. So this thing is for taking a binary input, a binary coded decimal input, which just basically means it only does the value, it only does 0 to 9, so it doesn't do anything else, which limits its flexibility, but at least it's something. It's a display driver, I think that's what they call them. And that's pretty much it. So we have to provide 4 different inputs. So a binary number that can take any in order to encode in binary a number between 0 and 9, we have to have 4 bits or 4 separate on and off things. That could technically code 16 different options, but most of the last 6 aren't going to be used. So, and this thing here it's got a sticker thing over it. We'll take the sticker thing off, the protective sticker. I'm kind of hoping that this one is an exciting color that's not the normal boring red one that these things come in. So I've got a lot of boring red ones because they're super cheap. I don't know why I keep buying these things. I bought 100 of these, the 4511s, because they were like 10 cents each for you buy 100, and I'm like, well, they're bound to come in handy for. Okay, where is it? They're bound to come in handy for something. Oh, you've got to be kidding. Okay, I'm going to use the chip straightener thing, and it was literally right in front of me, and I was staring at it, and I used it. I looked at it, and now it has disappeared. Where on earth would I have put it in that small amount of time? That was my one opportunity to use it. Hold on, I'm going to use this. It's got to be right. Oh, it's got to be under here. No, it should be behind the clock. It is behind the clock. Okay, I'm going to use this thing for once. So I'm going to put this in here, and then I'm going to squeeze it like that, and that's all that it does. And then hopefully it should go into here nicely, and it does. Yay! Finally. Alright, we've got 1000 ohm resistors, big chunky, huge chunky ones for this guy. So how is that going to work? So how does this thing get wired up? Well, I'm hoping it works like these ones. So they have these inputs and they're labeled, so each of the little LEDs on the 8 segment, so there's 7 segments, 7 segment display, and there's a decimal point, which we will ignore for now because we don't really care about the decimal point. But they're all labeled A, B, C, D, E, F, and G. and basically this I'm hoping this is a common cathode one. So the first thing we can do is we can actually test whether or not this is wired up like this. So I'm just going to double check that the pin's looking like that. So in these ones here, the common pin is usually the one in the middle on either side. So I'm just going to take this little wire. No, I'm not. I'm going to take one that's a huge one, and I'm going to put that one, and that one's just going to go to ground. That's the ginormous wire in the world. And if we turn it on, nothing's going to happen. But if we put here, and then that one, I think these are going to be too big, these resistors. It doesn't work. Uh-oh. What if it's common anode? Well, that's not good. I'm going to have to find another one. Have I got this wired up right? Nothing's missing. What if they have to be on the same side? You'd think. Nope, nothing happens. Alright, well then we'll have to try it the other way around. Oh no, 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 no. These are common anode ones. Why would I get that? Okay. Alright, okay. Well, it is blue. At least that's something. Where did I put it? Well, I should have... actually, there's a giant one of these things. Maybe I should use this one instead. But... in a little box of tricks, which you can't see, I'm going to get out this one. That better be a common cathode. I'm pretty sure these things only work for driving common cathode ones. Well, let's find out. So common cathode just means that the ground is common to all the so you basically supply positive voltage to the pins to make the light come on, and then the common pin is ground. Alright, well that's good, that's promising. It doesn't come on like it did a minute ago. So that one goes there, and that one comes on. Alright, so we won't get blue, we'll have to go with boring red. So boring red it is. The first thing is we're not going to use that. So where is... alright, let's just tidy this mess up. Alright, don't need that for now. Sorry, that's just a big one of those educational set things where you get lots of little components and it just happens to be sitting on the floor. It was my backup plan. I thought, why would I do that? I had some reason, I think, for buying a common anode one, thinking it might come in handy. Or it might just be that the blue ones only come that way. It could be that. Could be indeed. Is there a shorter one? There is. Alright, this is going to be one of those videos where you just make things. And I spend ages making it. And no one's going to watch. Alright. So we might be able to squish all these things in. Let's just have a look at the picture. So we have to actually have both these pages in front of me. So we don't need to look at that one. That's when the pins are on the side, and we don't care about that. And I probably should just check. So this pin, which was C, was lighting up that one there, which is C. So this looks like I printed out the correct way of these things are wired up. So let's just have a look at my picture, and I'm going to have it this way. And put those ones over there and be disappointed. Pretty sure this is a red and green one, so I'm quite keen on finding out how the two color matrix things work, and coming up with very silly games that fit in that small space. So we forget about the power for the moment. And alright, so C is going to be 1, 2, 3. So I'm just thinking about a few other things there. Can I make a big mess out of... oh, these are way too big to fit in here. but they're pretty sturdy once they're in. The only problem is that these are old, and they all have like some weird glue stuff on the bottom, so they're not the best kind of bits and pieces to use. Okay, so C and D. D has got to go one down here. Alright, this is going to be very exciting if I can get this. I've got to get everything in the right place, and they aren't allowed to touch the wires because that would just spoil the fun. So that's that one done, and we've got to do E, and E goes to pin number. Oh, that's quite nicely ordered, isn't it? So, oh no, I've done that one wrong, haven't I? Put that in the common cathode pin. Alright. And then we've got there's a lot of gunk on this. Yeah, because these resistors are what, I don't know, 20, 30 something years old. 20 years old, probably. Maybe even older, because I always think they're probably from the 90s or something. And that feels like, well, that's not that long ago. That must have been like 10 years ago. But it's not 10 years ago, it's 20 years ago. Alright. So I think that's set up right. So we've got the top one done. This is actually going to go real fast. It's going to be easy. And then, though I probably should put the wire in for the power to here while I'm doing it. Though it's going to get a bit nasty, isn't it? Because they're all going to all the outputs are on that side of the IC. So I have to get the outputs from this side over to here. But alright, so the positive one on a red wire. Where's the little red one? Oh, I'm getting to that point where I'm kind of like, oh, I need them to be matched up in the correct colors, which is not a good sign. I don't want to do that. It's my life's motto is be messy. That's pretty exciting. Well, they all light up because they've got floating inputs right now, so they're gonna change when I touch the thing, which is kind of funny when you got to look at this. Like I haven't actually hooked up the ground, so it's actually working without me even hooking up the ground. So that's really weird. Because actually, like, how does it do that? Like, how is this thing actually functioning when it's getting ground through here? There is a connection. There is a path to ground that goes via these resistors through here into here, but there's no path to ground other than that. So that's kind of cool. So let's give it a proper path to ground before it starts to react funny. So I do find this whole stuff fascinating when you don't wire up the power supply pins properly. And that they get them, and that the power, that things are going, not the power is going through, but there is somehow voltage differences coming out, potential differences coming out in the IC that allow it to function in a strange way. The paths are very strange. I don't know what the correct term is. But like I haven't even done, so there's all these little blanking and thing enabled pins you have to change. We haven't even done that yet. So we've got this, and now it's gone out. Come back on. Alright, so let's just get the rest of the pins in before we do all the important stuff. So we have to get B. B goes to pin number 12. So I feel like I should do pin number 12 last. I should probably do the ones on the... I want to do the pin that comes out. I want to do F next, because I want to do this one here. Because I think... Ooh, We're gonna keep this going while we're making it, because if I happen to blow this thing up, I have so many of them. As I said, I have over 100 at least, because I'm pretty sure I bought like a pack of 10 or something, and then I went crazy one day and thought, what the heck, I'm gonna buy 100 more. So I have at least 100, probably 110, probably more than 110. So if there we go, that one works. And it's quite good doing it this way. They keep coming on while you're building it. You know that you're on the right track. And so well, you don't know that you plugged them into the IC in the correct way, so I suppose that's not helpful. But G is the next one. Where's G? So I want G to go, G goes into this pin. So we're almost actually, we've got 2 more pins to go. 1 more pin. 2 more pins to go. That one's not lighting up. That's a bit disappointing. Light up. There we go. They're all on. I shouldn't be doing that, that's for sure. Oh, it's all gone out now. Come back. Come back. Alright. Oh. Alright. Oh, there we go. It's a weird symbol. It's probably trying to make a 4 or something. So this will be the interesting thing, is it is going to be trying to make numbers and not just randomly lighting up the LEDs. So we can assume it's attempting to make, well, there can't be a 4, can it? We'll have to make an 8. Alright, so what's the next one we haven't done? We haven't done A, and A goes, that's good, that's the next one along. So I have to say, out of all, you know, this is a reasonably intelligently, oh, we're gonna have a few problems here, aren't we? We're gonna have to link the wires across, I think, because I don't think, maybe I should have gone underneath. Oh well, too late now. Where is, we'll just have to use a rubbishy jumper wire to connect it up. So we're going to have 2 rubbish jumper wires. So that one can go there. And we'll put those 2 there, though I may have to change the location for that. So yellow is going to be number A, so that one can go there, and obviously the last one can go there. We haven't put the low resistor in. Well, this does not seem right. What have I done wrong? A, B, G. Well, we put G in. Oh, G did light up, so G will come back at some point. And then this one. Ooh, this one's... Alright, so this one's got to go into pin for the G. For which one are we doing? We're doing B here. So that's B. B goes to pin number 12. Good old pin number 12, which is, we're not going to be able to get this. Okay. Okay, alright, we'll have to undo that one for a second. Put that one in there. Oh my gosh, it is a mess. I may have to just, well, the intelligent thing would be to cut the legs a bit. And then that one's going to go over the top. So they're going to be mixed up like that. Alright, well, let's just quickly test this. So we're going to put 4 wires into the data things. And there. I thought that was, ooh, that was wire crinkling for a second. Oh, not wire crinkling, there was something crinkling on the desk, and I thought that was this thing making, I put 5 wires, alright. And the last 2 go on the end. So we should, now that we've got it, we should be able to generate numbers by attaching these straight to the, so is that working? No, it does not appear to work. Because that's not the number that you want. Nothing is changing when you do this. So I haven't got anything touching, have I? Because you'd think I would have something touching with this mess. Alright, that one goes there, that one goes there. Alright, maybe we're going to have to tie the last pins together. So there's 3 things I haven't done yet, and I'm going to have to take those off for a second. So there's a blanking enable, so you can blank the output. There's a lamp test, which just turns everything to 8. So maybe I should just have a quick look. Blanking, latch, enable output, that's what we need to do. So that we just make that high all the time. So when the latch enable is high, which is pin number 5, which is going to be the middle pin. Is that right? No, it's not. So it's going to be this pin here. we did something, it's gone out. Okay. So it says 0 now. That's encouraging, right? It's not saying it's not saying some weird digit yet. So now it says 8. So that's the latch enable. So when that's high, the output, the internal, the value on the inputs will go to the actual display. And if it's low, you can change the inputs around, and the display won't change, which can come in handy for things. For my use of this in an Arduino project, it's not going to matter. Well, it will matter. We just keep it latched all the time, and it doesn't. It's not clock latched, so it's not like so what's this? Blanking, ripple, blanking input. Active low. Well, we don't want to blank it, so we'll put that high, and that's going to be the next pin along. So, I'm hoping that it will work properly once everything is plugged in. I hope I don't have to change. I hope I haven't actually damaged the IC, because that's going to be hard to replace. And that little mess that I've made. And we need one more wire. We'll just use an orange one, and it can go all the way across. And it's going to be, so the last wire is this lamp test. Lamp test is active when it's low. Well, we don't want that to be active, because we don't want to test the lamp. And that's probably what's making it an 8. Because if it's floating and it goes high. Alright, so if that should have actually changed the output. Well, this is disappointing. Maybe I've got this wrong. Maybe it would change that one to... This is the awkwardest way of doing this. Well, that's not helping. Okay. So, I don't think anything is terribly bad here. Like, it looks like a complete mess, but it all seems to be wired up properly. I'm going to need... So I'm going to take this one out, and we're going to see if the blanking enable works. Because, well, that seems to work. Alright, so when you blank, when you set the blanking enable low, the blanking one, it does blank. So that's cool. So the only thing is, maybe the latch doesn't work the way I think it works. I've only printed out one page of the instructions. Oh, come on. Okay. If you thought, oh, you know, you like watching people, I think I've commented on this, if you like watching people make beautiful bits of art when they build these things, you've come to the wrong channel, so just go somewhere else. And so what do we have to do now? I want to change that green wire. So latch enable. It says latch enable input. Active high. Well, it is high. So what happens if we make it low? Then hopefully it will change. Oh, now it's gone to that. It says E for error. I think that's like kind of 2, 3. Alright, so I think, right, what have we done here? So is this the correct value? I think it says 3. So 3 we've got, so D1 is currently high, and D2 is low, D3 is low, and D0 is high. So that's a binary value of 1100, which is 3. So if I change this one, it should go to 2. Alright, and if I change this one, so this is the highest one, this one should then go from, this should go to 9, not 9, this should go to 5 if I plug these two in. No, it won't. It will go to, alright, so it will go to 9 minus 4, oh, it's gone out. Okay, we're going to have to think this one through. That's 8. Alright, of course, it is 8. Okay. I know what I'm doing. So I put these two low, and then I put this one. I'm pretty sure it works. That's 0, because they're now all 0. So they're all low. That makes sense. And then that one going, that should make it 8. Alright, so let's put this on the little tiny board that I had. Where did I put all those little switches? Alright, hold on a second. How much time have I got left? 3 minutes. Oh no. I don't know if we're going to have time to do this. We're going to have to use this because these are the only buttons I can see off the top of my head. So that one. These are the worst buttons in the world. Alright. I don't think I can do this in 3 minutes. Alright, so maybe we can. So these are buttons here for like VCRs. And they have the worst little legs. And I've literally got millions of these things. I haven't got millions, of course. That's not a real value. But how's this going to actually work? Oh, I don't see how it's going to work. No, I don't even know if they're going in the holes. The legs are so flimsy that they just sort of fall over here. Alright. So somehow I have to link all of these to one thing. Why am I doing it on here? Yeah, that's just not working. This is a mess. This is not possibly going to work. Well, it's got to reach the same one. Alright, there we go. There we go. All good. All good. Alright, and while we're here, that one's going to go to there. And then this one's going to also go. But we still need the pull downs. Well, this isn't going to work. Or it's not going to work. 1 minute and something seconds. This is getting super silly. Alright. I'm just going to use these wires. That one's going there. That one's going there. These all need pull downs to 0. That's 1. We're just going to use the 1000 ohms. Oh no, 50 something seconds. It's not going to work. Oh my gosh. Oh my gosh, this is terrible. Alright. 43 seconds. And I won't have any room if I do this. That's being pulled down to there. And this one has to get pulled down 20 something seconds. So I've actually done it. I think so. So 0, and these buttons don't work at all. That's because this is attached to the wrong thing. It's got to attach to that one. Alright, 2, 4, 8. And whenever you hold them down together, we can make different numbers. It works, kind of. And if you hold down too many, it goes too high and it blanks. So that will come in handy later on. So hopefully you can kind of see